Tutorial number 10, question number 1. The truck carries a 1.5 meter diameter spool of cable with a mass of 0.75 kilograms per meter of length. If the truck starts from rest with an initial acceleration of 0.2 standard gravity, we need to determine the tension T in the cable where it's attached to the wall. First, we have the radius of the spool where it has cable, which is equal to 1.5 over 2. This is equal to 0.75 meter. Without cable, it's equal to 0.53 meter. The mass of the empty spool is equal to 140 kilogram. According to the question, we can know that the tension comes from the acceleration of the truck. So we can start from the definition of it. So A, which is equal to alpha times R. Alpha is equal to A over R. This is equal to 0.2 times 9.81 over 0.75. This is equal to 2.62 radian per second square. And if we assume this is our point O, then the sum of moment around the point O is equal to IO times alpha. Then I is equal to empty spool plus with cable. This is equal to 140 times 0.53 square plus 150 times pi times 1.5 times 0.75 times 1.5 over 2 square. So this is the turns. This is the D, diameter. This is mass per meter. The total is the mass. So I is equal to 338 kilogram times meter square. If we put our I back to our equation, we will have sum of moment around O is equal to I times alpha. This is equal to T, which is the tension of the cable, times R. T is equal to I alpha over R. This is equal to 338 times 2.62 over 0.75. This is equal to 1177 newtons. Question B, we need to find the tension. We need to find the normal reaction under each pair of wheels. So if we take a free body diagram of the spool, it have reaction force Rx and Ry and the tension T. Force, the sum of force is equal to Ma. Then in x direction, Rx minus T is equal to Mo plus M times A. Rx is equal to 140 plus 150 pi 1.5 0.75 times 0.2 times 9.81 plus 1177. This is equal to 2490 newtons. Ry is equal to Mo plus M times G. This is equal to the same times 9.81. This is equal to 65770 Newton. Right now we need to take a free body diagram of the whole truck. Where it has the reaction force from the cable as well as the spool. This is Ry, here is the Rx. And we can mark all the lengths we have right here. By the way, here has the mass, this M2G, here's MB, here's NA. This is 0.75. Here is 0.5. This is 1.8. So M2G is equal to 2030 times 9.81. This is equal to 19910 Newton. Acceleration is equal to 0.2 times 9.81. This is equal to 1.962 meter per second square. So MA, if we set this our positive direction, it's equal to M2AD. This is equal to M2G times 1.8 meter minus MB times 2 times 1.8 minus Ry times 0.75 meter plus Rx times 2.4 meter. This is equal to 19910 Newton times 1.8 meter minus MB 3.6 minus 6570 times 0.75 plus 2490 times 2.4. This is equal to 2030 times 1.962 times 1.05. In y direction, it's equal to 0, then NA plus MB minus 6570 minus 19910 is equal to 0. Then NA is equal to 17980. MB is equal to 8500 Newton. Question number 2. The 22mm thick uniform steel plate is being pulled very slowly into the position by the cable connected to a winch. If the cable breaks at the instance represented, determine the magnitude of the force under each roller and the vector's acceleration ag of the center of mass. First, we know that density of the steel is equal to 7830 kilograms per cubic meter. And the plate has a force, reaction force, MB and NA. And also the gravity, which is mg. So we assume this is C. We can have the equation B sine C is equal to R times 1 minus cosine theta. So C is equal to 7.7 degrees. At the same time, mass is equal to ABT. T is the thickness, and rho. This is equal to 3 times 6 times 0.025 times 7830. This is equal to 3250 kilograms. First, we can solve the problem in the kinetic way. So the sum of force in x direction is equal to MAGX. Then MB sine theta is equal to MAGX. The same equation for y direction. NA plus MB cosine theta minus MG is equal to MAGY. And also in our k direction, the moment is equal to IG alpha. Then NA times negative B over 2 cosine C plus A over 2 sine C plus MB B over 2 cosine theta minus C minus A over 2 sine theta minus C is equal to I alpha. Then I is equal to 1 over 2 MA square plus B square times alpha. Here's our three equation. We can also think in the kinetic way. This AG is equal to AA plus alpha times RG with respect to A minus omega square RG with respect to A. This is equal to omega is equal to 0. Then RG with respect to A is equal to A over 2 sine C plus B over 2 cosine C in I direction minus A over 2 cosine C plus B over 2 sine C. This is our J direction. This is equal to 2.77 I minus 1.888 J. We can put this into our equation. Then we have AG is equal to AGXI plus AGYJ is equal to AAI plus alpha K times 2.77 I minus 1.888 J. Then in I direction, AGX is equal to AA plus 1.888 alpha. AGY is equal to 2.77 alpha. Here's our equation number 4 and 5. Then AB is equal to AA plus alpha times RB respect to A minus omega square RB respect to A. This is equal to 0 again. RBA is equal to B cosine CI minus sine CJ. This is equal to 5.95 I minus 0.804J. Then AB, AB cosine theta I minus sine theta J is equal to AAI plus alpha K times 5.95 I minus 0.804J. So in I direction, AB cosine theta is equal to AA plus 0.804 alpha. In J direction, it will be negative AB sine theta is equal to 5.95 alpha. Here's our equation number 6 and 7. Here we have 7 unknowns and 7 equations, so we can solve the whole for 7 equations. So Na is equal to 15.93 kilonewtons. Mb is equal to 18.33 kilonewtons. Ag is equal to 2.6 I minus 0.782 J meter per second square. Alpha is equal to negative 0.282 radians per second square, counterclockwise. AA is equal to 3.13 meter per second square. AB is equal to 3.36 meter per second square. Question number 3. A uniform disk with a mass 24 kilograms and a radius 0.3 meter is initially at rest. It is then acted on by a constant 100 Newton force as shown and rolls without slipping. We need to determine the velocity of its center of mass after it has moved 1.8 meter. First, we can calculate our initial kinetic energy, T1, plus the work done by the force, which is U122, is equal to T2. And because it starts from rest, then T1 is equal to 0. T2 is equal to 1 over 2 I omega 2 square. I is equal to 1 over 2 mr square plus mr square. This is equal to 3 over 2 mr square. This is equal to 3 over 2 times 24 kilograms times 0.3 meter square. This is equal to 3.24 kilograms times meter square. And the work done by the force is equal to P delta X. The P is 100 Newton. Delta X is 1.8 meter. This is equal to 180 Newton times meter. Then 0 plus 180 Newton meter is equal to 1 over 2 times 3.24 kilograms times meter square times omega 2 square. Then omega 2 is equal to 10.541 radians per second. Because there is no slipping, so G is equal to omega r to 10.541 times 0.3. The Vg is equal to 3.162 meter per second. In x direction, The sum of force is equal to MAGX. Then VG square is equal to VO square plus 2AGX times delta x. VG is equal to 3.16. VO is equal to 0. 2 times AGX times 1.8. So AGX is equal to 2.78 meter per second square. Then P minus FF is equal to MAGX. This is equal to 100 Newton minus FF is equal to 24 kilograms times 2.78 meter per second square. Then FF is equal to 33.3 Newton.